Hey y'all, my name is Eric, and this is my lab 4 on oscillations. So the purpose of this experiment was to analyze a spring system and observe the motion through tracker and compute the motion through growth script. And then we then compare the two models in terms of their change in energy, their x motion, and their y motion. So some fundamental principles are Newton's second law, where force is equal to mass times acceleration, kinetic energy, which is equal to 1/2 mass times velocity squared, gravitational potential, which is equal to mass times gravity times change in displacement, spring potential, where it's 1/2 k constant, and the stretch or compression squared. And then we have our position and velocity update formulas. So here is the tracker video I used, and this is just a demonstration of, well, how I did it. Yep, that spring is definitely moving. Alright, so this is the growth script code that I used. On the left, we have the system's mass and the initial conditions. Now the mass was given through the video, that the pre-lecture videos of 0.402, and the position, the dot position vector is from my observation on the tracker, which was negative 0.08259 in the x direction and negative 0.659 in the y direction. And similarly, the k constant and the relaxed length of the spring are from the lecture videos. And the next three lines down there are just where I find the L hat, and then I was able to find the S. And then the next four lines after that is just the equations of the kinetic, spring, gravitational, all those equations I mentioned earlier, but written in code. And total energy is equal to 0. And this is just a continuation of the glow script. So we define the initial energies at the top, and then we account for gravitational force, which is equal to the mass times the gravity. We account for calculating the spring force, which is equal to negative ks times s times l hat. And then we use the net force, which is calculated by adding the spring force and the gravitational force. And then by using the position and velocity update formulas, we can, well, find the updated position and velocity updates. And every time this code runs, the spring gets updated by repeating the equations from earlier. And then the bottom is simply just the equations again, except repeated. And by doing all that, this was the energy graphs I got. So as you can see, delta K sim oscillates, and delta U graph and delta U spring, they oscillate too, except they oscillate in, like, I guess, like they're reverse of each other. And delta E, which is change in energy, remains constant at 0. And this is the X and Y position graphs. As you can see, it's a little it's not perfectly aligned, which could be due to the fact that I may have not accounted for drag forces, or I simply, on the tracker I may have not properly centered it at the center of mass, which in this case every little error could account for something here. Now, in regards to the energy principle, the energy principle is satisfied. So in this whole experiment, the system is a spring, block, and earth, whereas the surroundings is everything else. But since we basically include everything, the surroundings has nothing. Now the energy principle is equal to the change in energy, which is equal to change in work plus heat transfer. Now, since there is no surroundings, there is no external forces going on, so there's no work, and there is no heat transfer in the whole process. Therefore, there is no change in energy, and it remains constant at 0. And as I mentioned before, the kinetic energy oscillates, while the gravitational potential and spring potential are essentially vice versa of each other, so they will cancel out. And this makes energy equal 0. In addition, the oscillations for the x and y components, I just simply went on tracker and I put my cursor around here, as you can see here, for the x, and the y right here. So I got the x oscillation to be roughly 2.2886 seconds, and the y position oscillation to be roughly 2.190 seconds. And the slight difference could be attributed mostly human error, as, like I said, every small difference accounts for something here. And yeah, that's pretty much my experiment. Thank you.